I'm going to go over ideal gas law. This is our last gas law. An ideal gas law looks at all of our variables for our gas and puts them in relationship to one another. So ideal gas law is looking at pressure, temperature, volume, and moles. And in this particular case, our equation for this is PV equals nRT. And so all of these should be pretty familiar except for one of them. I'll just go over them really quickly. The first one is pressure. That pressure will either have to be in atmospheres or in kilopascals. You will have volume. Volume, when you're using this equation, always has to be in the unit of liters. We have moles of gas, which will be in the unit of moles. We have R, which is brand new, and I will talk about that in a moment. And we have temperature. And when we're using gases, our temperature will be in Kelvin. So you should always be plugging temperature into your equation in Kelvin. So if we're looking at all of these, the only one that you don't know is R. And so what is R? R is our constant. It is a numerical constant, in fact. So there is a given amount for R. There's a given number, numerical value for R. And there's going to be two to choose from, and I'm going to talk about that in a second. But R does a couple of things for us. The first thing that it does is it relates all of our variables to one another. The other thing it does is it helps us cancel out the appropriate units. So those are really two important tools for us. And I will be showing you how to use R in the future. But these are our two values of R. So the first one is 8.31 liters times kilopascals over moles times Kelvin. Now this is not an equation, so not an equation. What this is, it's a value with a complicated unit at the end. So like density is grams per milliliter. Well, R is liters times kilopascals over moles times Kelvin. That is its unit. So it's not an equation, it's a value that has a very complicated unit attached to it. And what you'll see is that it has all the units that we need in order to look at these variables in our equation. So it has liters for volume, kilopascals for pressure, moles for N, and Kelvin for temperature. So we will only use this R, this value of R, if our pressure is in the units of kilopascals, or if we want our pressure answer to be in the unit of kilopascals. The other value of R is 0.0821, that's a decimal right there, liters times atmospheres over moles times Kelvin. Again, not an equation, it's a value with a complicated unit at the end. And you'll notice that this unit is slightly different because it is in atmospheres. So you will use this value of R anytime your pressure is in the unit of atmospheres, or if you want your unit to be in the pressure of atmospheres. And in order to remember the ideal gas law, most or a lot of people refer to the equation as PIV-NERT. So PV equals nRT, we will be calling that PIV-NERT.